Thank you, Jason. And we really do have a great panel with us today for today's kickoff keynote that I think does get to the point of what we're trying to explore with this event, which is what is the department actually doing with cloud and why does it matter? DoD's obviously been talking about cloud for well over a decade. And as we all remember, that early part of the conversation was mainly along the lines of, can we save money by putting some stuff in the cloud instead of government operated data centers? And we really are now well into the part of the evolution where everybody's moved way beyond that and thinking about how it's a mission enabler. And then you get to the point, I think, maybe 3, 4 years ago, where people are thinking of cloud not just as an enabler in the sense that DoD, maybe business and logistics systems can actually work in that space. But now we're actually thinking about how battlefield tactical intelligence systems can use cloud native architectures and connect with those cloud hosted logistics systems. And if that all works right, suddenly you're off and running with a network that really does look absolutely nothing like it did a decade ago. The Army is thinking in particular pretty hard about all this stuff. Paul Puckett, the director of the Army Cloud Management Office, is our guest in another one of our sessions later today. And I would really encourage our attendees to tune into that session to get a better sense of how these piece parts all fit together. But for this one, we really are going to focus on the tactical edge. And we've got 3 guests with us to help do that. Alex Miller joins us from the Pentagon. He is Senior Advisor for Science and Technology for the Army G2. Dr. Portia Crow is the Chief Data Officer for the Army's Network Cross-Functional Team, and Ken Lawrenson, the Product Lead for the Mission Command Support Center at Army PEOC 3T. And Ken's kind of the point person for working with industry to build out those tactical cloud capabilities. Thanks everybody for doing this. I know you've already got really busy schedules, and I appreciate you taking the time to talk a bit with our audience about where cloud really is headed in the tactical space. And Alex, I think it makes some sense to start with you to kind of lay out the landscape a little bit here. You've been working in the Army intel business for a long time, so part of you're part of the Army family that cares a lot and always has about collecting and aggregating and distributing data in the best possible ways. We'll get into how cloud might be able to help with that as we go along, but maybe you can just start us off by giving us a little bit of insight into the challenges you're dealing with. You know, what does the data environment look like now at that tactical edge in the intel space? What challenges does that present for Mission Command for intel as of today?
Absolutely. I like this question because anytime someone says, hey, what's your problem before jumping to a solution, we know that we're moving in the right direction. And I'm going to talk broader than sort of the intel problem, but just talk the Army and probably really the joint problem. I would say we have been decisively and consistently engaged for 20 years now. In fact, I was talking to my dad last night and he goes, hey, today's the 30th anniversary of our invasion into Operation Desert Storm. So if you think about how long the Army has been engaged, it's really almost an entire generation. And during the global war on terror, we consistently duct taped things to the architecture to make sure that we were delivering capability rapidly. And that took a lot of different forms, and technology evolved a ton over that time. But what that left us with was a lot of debt. And that debt took the form of technical debt, process debt, organizational debt, talent debt. And really, as we start talking about our modernization towards artificial intelligence and machine learning and the operationalization of data science, those are the bankers that are calling in all those debts. So as we talk about cloud, I think the biggest problem we have right now is our data is really spread everywhere. Some of it is very relevant. Some of it has perished in its utility because it was very perishable to begin with. But when we start talking about how we're going to solve that, lexicon is probably our biggest technical and operational hurdle, because cloud means a lot of things. And even in the commercial world, the term cloud has evolved. So really, cloud is someone else's computer. So if you're holding on to a piece of kit and you're saying, hey, this is my cloud, you're really not using the cloud in the technical sense. Well, we know that we can't we can't rely on reach back all the time. We can't rely on the internet to solve our problems, because we will be operating in environments where we just don't have access. So for us to be able to clean up our lexicon and say, hey, not every problem is a cloud problem, but the cloud will help us solve some of our problems, like workflows, like cognitive processes, like aggregating data in a place where we can sort of touch all of it at once, and then provision or take some of that with us into the tactical space. that's where we have the biggest amount of challenges, because once we solve those things, once we clean up the data space, we have the ability to apply analytics or apply some of these advanced artificial intelligence methods to that. So I would say that is probably our biggest problem. And then the thing that keeps me up at night about that is the supply chain to support it. And that is the talent supply chain, the technology supply chain, the data supply chain, and how we actually work through all of those problems to make sure that we have a force that is technically savvy enough to employ it, and then a culture that is technically savvy enough to buy it, to employ it, to use it, to sustain it, and then to really understand it. So I would say that that's where we are in the space right now.
Yeah, and maybe foot stomp that a little bit. I think part of the key issue here is that cloud technology itself is changing very quickly and will continue to change over the next few years. So maybe this is another thing that keeps coming up during this conference is, we're not doing cloud for cloud's sake. And considering that rapid pace of change, those foundational elements that you just talked about, Alex, are probably more important. Getting that common data fabric right, thinking about the lexicon of technology in different ways so that you're ready the next time the next cloud evolution happens. Is that a reasonably good way to think about all this?
It is. Any significantly advanced technology has dependencies and enablers. And traditionally, we pilot chasing the technology itself, and then we work our way back into what that foundation should look like. And cloud is certainly no different. I remember in 2010, we were having very similar conversations about the first instances of big data platforms and big cloud platforms. Google had recently published the big data paper, or the big table paper rather, and we were trying to figure out, hey, what does this really mean to us as a department when we are going to put all of our data in one place, all of our infrastructure in one place, and how do we leverage that? So yes, absolutely.
Dr. Crow, let me turn to you on this piece a little bit. Talk a little bit about what the network CFT has actually done to think about cloud services at the tactical edge. Again, whatever form the specific technology is going to take. What are you looking at there?
Sure. Thanks, Jared. So I would say, and I love that we started with the problem statement, because to me, cloud is just a solution. So let's start with the problem and how cloud has given us the ability to solve those problems. So we are, as Alex said, there is a vast data set out there for the Army, right? I mean, we collect data. Data is not our problem. It's how do we aggregate it? How do we take that data and actually make informed decisions from it? So the cloud not only allows us to have secure data in a global capability that we can access it, but it also allows us to aggregate that data in a way that we can make informed decisions. So doing high fidelity AI analytics from that data is really key for us. The other aspect that we have to look at is from a network perspective is our transport, right? So what is that transport capability? How do we get resiliency out of the network that we have and in the locations that we have? Because not all places do we have fiber connected clouds, right? I mean, we have a dispersed, we have latency issues, we've got a lot of environmental issues that we have to deal with, right? So is that cloud, whether it's on the enterprise or we have cloud technologies local to us, how do we enable our soldiers to get the best and the fruitfulness out of our data? So the network CFT has kind of taken on that challenge a little bit with our key partners, which we have many key stakeholders, and of course Alex and our Army G2 is definitely one of our stakeholders, and really helping us kind of move through how do we put the data that we need for all the way down to the tactical edge in a secure location and allow us to do some of that. So sensor shooter is very critical to what we do in the Army. And so we are enabling that by getting software to the hands of the soldiers faster, right? And so one of the problems that we've seen in our journey to Army modernization is how do we develop software faster? How do we get soldier feedback faster? And then how do we get that software in the hands of actual soldiers, right? So I think streamlining the accreditation process has really helped us along. We've also are using a DevSecOps called Orion Forge to allow us to bake in security earlier rather than later so that we don't have that time lag of, the waterfall process of doing things in blocks, but we're doing things in parallel. So with Orion Forge, it's not novel that people use DevSecOps, but what is novel that we are doing is that we're solving very discrete critical problems in a tactical environment, and we are streamlining the accreditation, right? And so it allows us, like I said, to enable faster, more rapid production of software. Along with that, with the data piece, I'm a chief data officer. I got to talk data a little bit, right? And so, how do we use that DevSecOps and the processes that we're putting together to create common standards, right? Or use common standards. And so Alex alluded to, our joint services, right? So we have a great ongoing partnership with the Air Force right now where we are doing data exchanges. We are using data libraries. We're using common industry standards to share data between the two services in a very critical space, everything from air to ground, right? And that alone has allowed us to really open up the opportunity space of what we really need to share and be time sensitive about sharing that data. So as we talk about digital modernization, I also want to talk about digital infrastructure, right? And that's really where the cloud piece comes in. So how do we bring in cloud into our experimentations? How do we bring cloud really to the forefront of getting the software out to our soldiers faster? So with the creation of Orion Forge and our partnerships around that whole entire, what I call it kind of like a mini ecosystem, we are making great progress. We're already in operations, and so it's been very exciting past few months.
Definitely want to come back to that Air Force partnership and the DevSecOps getting stuff out faster piece of this. But just to return to the cloud architecture piece a little bit, I'm sure it matters in terms of how you think about designing the network, how much data and processing you think you can do forward versus what is going to be in some commercial data center somewhere or in some commercial cloud somewhere. I mean, that really influences the design decisions that you make on a year-by-year basis, I would have to imagine. So what's the current thinking on proportionality in terms of what needs to be forward versus what you can do offline, for lack of a better word?
The big picture here is that when we issue servers to units, there's always a constraint of what we call SWAP, size, weight, and power. You can't give a unit a computer the size of a minivan, right? The ideal computer to give them will fit in their pocket, have infinite capacity in processing and memory, and require basically no power. That would be a hopeless ideal, but that would be kind of the ideal. So the type of trades you make with the amount of processing you can actually do out on the front line is going to be constrained by the amount of basically logistics and capacity they have to actually bring that kind of equipment forward with them. And that depends on what echelon of unit you have, the type of mission you're in, the type of threats, your mobility, and all of that. So now you introduce cloud, you could say, well, fundamentally, I've got now an infinite amount of capacity behind me here if I can reach it with my network. So it's exactly the question you state is where do you start making the trades and what can be done, where some things we wouldn't have considered even doing because we would never have a computer powerful enough to make those kind of analytics possible, especially when they're being effectively constraining the amount of information that they could have on tap at that point anyway. So that's, when we look at things where, let's just say hypothetically, we're looking at route planning. And we're not talking about route planning where you've got roads. We're talking about mobility of a force through a forest, through mountains or something like that. If you can reach back to a cloud that has a very feature-rich geospatial data model, and they have the data on tap for mobility of particular vehicles and forces and the types of amount of fuel you can consume, and you can have it develop courses of routes, that would trade either the speed of movement with the shortness of distance, based on the same way you would use Waze or Google Maps or something like that. And that would normally take an enormous amount of cognitive planning for people to kind of realize what that would be, looking at imagery and topology type maps. And now we get the computer to kind of do it the same way Waze would do it for you and be able to do it in a moment, not over courses of hours. And then bring those waypoints forward to a commander in the field and say, look, based on the computing happening in the cloud, this is 3 or 4 viable courses of action with the following trades associated with them. And that gives them, decision speed that was just, unheard of, and we wouldn't even have been able to consider doing that kind of a processing up front, but now we can. And those are it could be associated with weather, it could be associated with large-scale troop movement and logistics support to them, mobility types of calculations where, the cognitive load would just be enormous on people. But as long as you get the right data into that computer, that cloud in the sky, so to speak, those kind of trades become possible for our commanders, and that's the kind of thinking we need to do, and that's the kind of thinking we need our industry partners to come in. Don't help us do what we can currently do, with a cloud. Help us do the things we can't do now, by using the cloud, and that's a big part of this conversation.
And Ken, all those capabilities are certainly exciting. How real are they, or how real might they be in the next 3, 6, 10 months? What sorts of experimentation is happening right now, either in the lab or in the field, to actually prove these things out?
Yeah, so we're, majority of the things we're trying to do right now is we need to recognize that we have an enormous investment in the software and systems that we have. We also have an enormous investment in the way we train, the way we use these systems. So there's kind of let's call it a hysteresis that has to be overcome in the way we think about the way we do our systems. And we also have to recognize that we don't have infinite budget and contracting ability to move forward. So the things we're looking at right now is if we have what we have right now and we move it to the cloud, whatever that means, a lift and shift as they typically, what are we gaining anything out of that? And typically, I'm going to say, the only thing we're gaining is an ability to probably provide the capability to folks that normally wouldn't get it based on training scenarios for the most part, right? So if we're in the business of giving a server to every unit in the Army to do what we currently do without a cloud, right, that means that only people who are near that server at that point in time can do anything. But if I have capability hosted in a cloud where I can provide training contexts and planning context to folks that normally wouldn't have access to the capability, now I've got a readiness factor that's very significant. And I've also got a proficiency and experimentation venue that also allows us to start asking the question that you originally asked is, if I have a cloud, what can I do with it? Those kind of questions. And that's what we're doing right now with some of our pilots. We take what we have, we put it up there, and we figure out where the Achilles heels are, what are the limitations. And a lot of it has to do with the way, and it gets back to exactly what Portia and Alex said earlier, was it's the way we deal with data. Our systems are information-driven systems right now. We pass messages, we pass reports, we pass alerts, and you can almost imagine them being just virtual file cabinets of reports, alerts, and warnings, and those kind of things. And we save them, but there's no way to really traverse them. There's no way to get second-order kind of knowledge out of them unless we have to start ingesting them. The whole initiative of data fabrics and the ability to put AI into to see the kind of second-order analysis and value you can get out of all of these reports we send all over the place is just something that's not explored because, quite frankly, it's just computing that we couldn't do it before the cloud capacity and the technologies associated with it became available to us. So those are the kinds of things that we want industry to start exploring. Is we see it all the time in the commercial world. The marketing folks do it all the time, and the social media, the social networking, and all of people getting together and exchanging ideas and be able to pull together basically trees of information and traces of information that just gets done because the technology supports it. That's the kind of thinking we need to bring here. Our soldiers, because of their age, they're coming in, they grew up as kind of smartphone IT kind of kids, and they're fantastic. And we get so many ideas from them because they bring it from their day-to-day lives and how they use computers just to balance their books and shop and do whatever they do. But that's the exploration we really need to think about. And we're driven by doctrine right now, and exchanging messages and very hierarchical kind of thinking. Orders go down, reports go up kind of thing. How do we get around that from our IT systems that are currently designed for that mentality and get into a more global shared data context that allows us to think and reduce cognitive burden and come up with better decision assistance type algorithm and things like that. That's really where we got in.
This is probably for Alex, but anybody, please feel free to weigh in. Can you give us some sense of how far along you are in figuring out what data matters, both to the Army, to your joint partners, to coalition partners, that's actually going to be useful to put in the cloud, so that you're not just, as Ken said, lifting and shifting everything you got to that environment?
Yeah, this is a super astute question, because a long time ago we used to say, hey, all of the data matters. And I would augment that with all of the data matters sometime. So data has a life cycle and a lifespan, and most of it is very perishable. When an event happens, there is huge amount of forensic utility as long as the event it leads to something else. What we don't want to do is try to move all of the data all of the time, or store all of the data all of the time, especially from the edge back, because what that generates is this little r requirement for all of this massive storage or a ton of bandwidth. And Ken put it pretty eloquently. We can't do that. The swap isn't there. The ability to move bits and bytes over the network all the time isn't there, especially if we're going to be in an anti-access area denial type of environment. So I'm sort of shifting the focus of the question into what are we doing about the problem? And really it's getting after smarter sensors, smarter processing, and then working to reduce the cognitive burden on analysts or logistics technicians or mission commanders by saying or doing or automating pieces that take data, pull out some nugget of information or some insight, and then moving that into decision support utilities. Because the cloud is not an end state, AI is not an end state, analytics themselves are not an end state. Decision support and enabling humans to make decisions or adjudicate decisions is the end state. So we don't want to take all the data and try to mash it onto a dashboard. That's interesting, but it's not compelling. We want to take all those, use sensors that have onboard processing, which is a provisioned service from the cloud. We want edge nodes that are provisioned off of the cloud with cloud-enabled analytics so that we can reduce those data. And then we want to use a lot of the cloud-native architecture that's been pushed forward to enable that. And one really good example from industry is how Netflix uses their cloud. So Netflix is one of the biggest consumers of cloud services. They don't push every high-res 4K video down to an iPhone. What they do is for every frame that they take, they chop it into a bunch of different formats, whether you're going to be on a square monitor or a rectangular 4K monitor or an iPad or an Android or an iPhone, and they store those clips and they push those out to the users who need them based on the situation. So again, they have all of those big data in the cloud, but then they can ship it out and push out exactly what they need to the users that need them the most.
And I just want to drill down on what you were saying about smart sensors, Alex. Is the idea there that the sensor itself is doing some filtering basically for you, so that you're sending, instead of relatively raw data back to the cloud, you're only gathering relevant stuff in the first place?
It's a little bit of both. The easiest way is a metaphor. So take every selfie that's made in Washington, D.C. Most of those pixels are not relevant to the people who want them. It's the face, it's the smile, it's the companionship. We want to be able to take those and make sure that analysts aren't staring at pixels all the time that are empty or erroneous or irrelevant, and only making that human, who is a super valuable resource, look and analyze things that are relevant or will have relevance in the future. So yes, we want to reduce the amount of data that's pushed, not by collecting less, but focusing our collection and only pushing to humans what's relevant for humans to look at.
Dr. Crow, I saw you nodding. This is definitely your area of expertise.
It's great. It's a great topic and it's a great question. So I guess the way that I look at it, and maybe just because we've come out of a implementation of this, of your question, is that the Army has a learning campaign called Project Emergence. And along with that, the Joint Services has something called Joint All Domain Command and Control Experiment. So what we've done is we've taken key mission threads. I'll just use joint fires, for example. And we've broken that down into use cases, right? And so it is a visual flow of how data gets across the battle space from air to ground. And that is what data is exchanged, how it's being exchanged, what's the transport, what are those systems. And we've broken that down into, okay, if we are going to, for example, exchange air track data with the Air Force's F-35, where does that need to come into the Army? How does it need to come into the Army, and what is the best way to do that? So we've been using cloud as our way to actually exchange that data. And we do it fast, and we do it real time, and we do it securely, right? And so how do we bring that notion of using the cloud into those experiments, right? And so we are actively doing that right now, which I think is fantastic, right? And we are learning as we go, and we are being informed, and it's just opened up a lot of opportunities in the space. And so I think, as both Alex and Ken alluded to, we are very cognizant of connectivity, latency, bandwidth, and so I think a lot of those attributes goes along with kind of anything you're doing on the network, right? So, but what's exciting is that it's a new avenue of a way to exchange data, and to me, it's a little bit more modern than the brick and mortar and the labs and things like that. So how do you bring that into the context of what we're doing today in these big learning campaigns between the services? And so I think that's exciting, and that is really kind of what we're focused on right now.
And that takes us back a little bit to the partnership that you were talking about earlier with the Air Force. Can you give us some sense of how mature that is, what volume of data you're sharing and transmitting back and forth, and what types of data you've settled on for that initial round of experimentation? Maybe the wrong word, but whatever it is.
So I will say that the two service chiefs that in last year, late September, they had a great exchange, and it resulted in a memo that said, here are the key actions that we want the two services to do. And so we kind of network CFT with our partners, kind of have taken that on, and we've got a lot of great partners that are, hands-on. What does that mean? What makes sense? And so we really do try to follow. Not all the data do we need to be exchanged, right? So what is the critical data? And for us, using use cases really is helping us align what that data is, and then how do we share it? So we're just learning things like data libraries, right? Where's the Air Force's data library that stores this data? Where's the Army's data library? How do we use a common data fabric? So we've used the common data fabric to share data. So the formats, the data messaging formats between the two services are not necessarily universal, right? So we've used the common data fabric to ingest that data, kind of normalize that data, and then share that with the rest of the Army, right? And they've done that almost in real time. And we're also using mechanisms like infrastructure as code, right? Service as code, so that, we're able to, move a little bit faster than what we, previously have done in terms of timing. Because as Alex said, when it comes to sensor to shooter, timing is everything, right? Timing and understanding your data really gets us to the speed of what we really need to be at. So we're just on the cusp, I think, of understanding, each other's architectures, data libraries, data standards, data tagging. I think Alex alluded, already talked about, just getting the lexicon right? What is a common data? What is a federated data fabric mean across the services? And we've achieved that during one of our JADCC data summits. That we actually came out with a great definition of what that is. But I would just say that, we are just beginning to really get into, what is the realm of possibility. We have a JADC2 experiment coming up, and then we have Project Convergence at the end of this year. That's going to be really pivotal for us to keep up the momentum and keep learning and informing each other of what needs to happen.
Ken, let's go back to you for this next little bit. Talk us through a little bit what the command post computing environment looks like out in the field as of today, and what it might look like once you start introducing some of these cloud concepts and cloud technologies. How does it change?
Sure. So the command post computing environment, true to its name, is a command post computing environment. It's a command post designed, and overall it's peer to peer in the sense that we give that same kit to divisions, brigades, battalions, and when we get them networked typically over SATCOM communications, they function as peer-to-peers. Technically, operationally, we'll establish a division or a brigade to be kind of a senior node or a master node to a lot of them for behaviors. But overall, they're identical to each other, and they interoperate by passing messages, information amongst them. And once we start looking at a cloud now you establish a computing node that is effectively a persistent master node. A lot of those command posts aren't persistent. If they're a maneuver unit and they're going to operate for a day or a few hours even, they'll shut down and move someplace else and come back up. So you can't rely on them like a persistent data service, or like you would look at to a cloud, which is in theory never shuts down. So now we can start to look at the way our command post computing environment can lean into persistent computing in the cloud. And that allows us to trade a lot of responsibility that would be awkward, especially from an administration perspective or administrative, IT perspective, to lean back into the computing, to the cloud, and become not just a data manager, but a configuration manager and a master node for authentication, and be able to improve the mobility in which we reconfigure our computing nodes that are deployed, as well as the communication links that bring them all together. So the current way we do business is we manage a local store in our computing our command post, a data store. And that's, it aggregates the information that comes in, as I said earlier, with messages. It puts icons on the screen. It builds a picture, what we call a common operating picture. And it basically puts icons there. Here's the blue ones. This is where we are. Here's the red ones. This is where the adversary is. And, geographical type of markups for, where we're going to follow a path, where we're going to have communication assets, those kind of things. We build that as local kind of views of the data that we receive, the information it receives. Now we can go to the cloud and put a master node up there and say, we can do all that data fusion and that picture building in the sky, in the cloud, and then push it down and give it analytics that we never were able to do, either because we were starved of information locally, or it just didn't have the horsepower for storage and computing to do it, either practically with respect to time, or simply just to give that amount of computing horsepower to a unit that's trying to drive around in the middle of the woods or the desert or wherever we are. So the shift from peer-to-peer command posts, effectively as their own little data centers, to a more subservient master-slave or client-server type of role, where the servers in the command post become edge nodes, not unlike what you see with snowballs or outposts or the things that the commercial world is offering. They still are there and they still function, but they are now in a distributed computing context with the cloud. And just as I used with the Waze analysis, the cloud can become crowdsourcing. It can become an aggregate of all information and be able to do decision cycles, support that you just couldn't do in the local command post instances, and support the mobility, and support other things too, that cyber posture, cyber surveillance, the fusion of our data with intel that normally wouldn't make it to us. Those kind of challenges that we wrestle with all the time, because it's a more finite pool of resources that we have now. Now we can start looking at these, basically go in with a bigger appetite and start tackling some of these problems that we wouldn't have considered otherwise.
So everything that Ken just told us, I mean, a lot of radical changes in there, but one of the things that it portends, it sounds like to me, is pretty different jobs for the Signal Corps and for a battalion or a brigade S6 out there at that command post. Who's thinking through what that means for the workforce and for your talent pipeline? I mean, that's probably not necessarily a PEOC 3T job, but somebody's got to be. And what does it mean for soldiers?
Well, let me chime in on that, because that actually
Sure.
is something I think a lot of. So my day job, among my day jobs, we have the Mission Command Support Center here, and it's a center that's staffed 365/724. And the majority of it is providing help desk support to folks that need it with our systems that we have deployed, Mission Command and otherwise. We also maintain a satellite communication network for a Blue Force tracking system, right? So I have this organic staff here and in other places that are performing a real mission in support of the operational force. We do things on behalf of the operational force, so that because it's practical to do it in a centralized manner. So the question becomes, how does my mission grow here as we introduce cloud computing, right? Because we normally issue a piece of kit. We'll give a server to a unit and say, here you go, we're going to train you, call us if you have any problems. And we kind of step back and let them do their job. Now we're introducing something that isn't issued, it's effectively provisioned. It's something in the sky that becomes a capacity like a power plant, but they don't actually own and operate it unless we explicitly give them the responsibility to own and operate. So where do you make a trade between what the soldiers wind up doing on behalf of their unit, their mission, their theater, and what do we as the operational force have to pick up as either an economy or just practicality of maintaining this cloud infrastructure deployed to tactical missions? And that gets into how do you eat the elephant, really? Because the mission context in Europe will be different than Asia, will be different than Northcom, and you wind up with somewhere in here is an intelligent way to split that mission up, and not put any more burden on the soldiers than you have to. Ideally, the capability outweighs the burden, and at the same time keep things back because there's an economy of scale in centralized administration and control of a lot of this stuff, especially with cyber posture and maintaining, just patching things and stuff like that. That becomes a key capability that we can take out of the soldier's rucksack and make it so they can focus on their real job. So it's a great question, Jared.
So Ken analyzed the problem really well. I think the question is super important for our future because a lot of this starts at where we train soldiers initially, because the jobs of the future are going to be different. I mean, quite frankly, what soldiers do today to maintain the technology that they have today is different than probably what they expected when they came out of their respective schoolhouses. So the Intel Core, we've got 35 Tangos who are our maintainers. But when we talk about the future, this ephemeral future, our Signal and our Intel specialists and all of our logistics maintainers are going to have capability that it's not good enough that they can call a help desk to solve a problem, because I never want to be in a position where I am dialing 1-800 fix my cloud when I'm being shot at. And that is not a condition that we can put our soldiers in. So we either have to have some type of elegant failover for local capability, especially in the tactical space, or we have to upskill our workforce to the point where the bottom, the absolute minimum, is someone who is capable of analyzing a problem, synthesizing a solution, and fixing it locally. And when we go to industry to buy, acquire, adopt, adapt technology, we cannot allow anything to be bought that is not maintainable. Because what we will end up doing is getting something that is so complex, and rightly so, it's a complex problem set, but so complex that it's a black box to us when we acquire it. So there's a trade-off between how we acquire technology or adapt or adopt it, and how we train our workforce such that they can actually not only leverage and employ it for their day-to-day jobs, but maintain it in the field.
And I'll actually chime in there too. And I think we've been talking a lot about talent management, and so not only in the data science, data engineering, but I think cloud engineering and some of those cloud, capabilities that we need, we have to upscale, our workforce as well. And so I would also say that in terms of cloud contracting, right, that's a skill unto itself, right? And for me, getting the requirements right and also being savvy enough to write a good cloud contract to get the services that we need, that's affordable, is also a very needed skill today. And so I know that we are definitely, as the Army, we've got a lot of cloud initiatives going on. And so there's a lot of great initiatives in that space. So that to make sure that everything from data rights costing of your cloud model to the efficiency and cost as a service, and and things like that. I think that we're making really good strides in that area.
Along the lines of cloud contracting, as I understand it, the vision here is to do multi-cloud in the tactical space. When the planning for the Jedi contract started a few years ago, the idea was that it's just going to be too hard to orchestrate multiple clouds together at the tactical edge. Acknowledge that we're a few years down the road at this point, but do we now feel that that really is doable with today's current technology? And a second part of that question would be, what are the advantages, to the extent there are advantages, of a multi-cloud approach in the world of work that you guys think about?
So I'll jump on this because I'm the science and technology advisor, which means I get to be sort of or abstract. Every day I turn on my phone and I have access to polycloud technologies, right? I use Outlook, that's provided by Microsoft. I've got the Apple App Store, which is provided by Apple. I've got Gmail on Google. Like, a polycloud environment is not hard to materialize in technology. What is really difficult for us today is contracting in a way that allows us to leverage services, vice focusing on kit, because we buy things. It's very hard when we start shifting that to, hey, I want to buy a little bit of this service and combine it with a little bit of that service. And I don't know what the pricing model is for this over time because I don't know what my user base is going to do. So I want to echo what Portia was just saying about how we contract and how we buy things. But a polycloud technology ecosystem is not an unachievable goal. It's just something we're striving towards.
And just to add to what Alex said, is that, we want the innovation, right? So why put all of your eggs in one basket, right? And so the Army is all about innovation. So I think in terms of even making sure that we develop our software agile and flexible in a way that we can use multi-cloud, I think, there's some stipulations with common services for each of those cloud vendors. But I think that, if you use container technologies properly and you use the right technologies, and we have a common way of developing that software, it's not such a huge lift and shift when you want to use multi-cloud. And there are clouds that are not all equal, right? I mean, the Army's got classification criteria that we have to meet. We have certain ways that we need to use the cloud in terms of our data and the sensitivities of that data. So I think having options for us is a good thing. And then, of course, what problem are you trying to solve? Because not all clouds are meant to be the same. So what goes back to the problem that you're trying to solve, and how do you utilize all that you have at your fingertips to help you solve those problems?
On kind of a related question, getting back to what you were mentioning earlier, Portia, about moving toward DevSecOps and continuous delivery and faster development, do you get to the point soon where you're able to push software updates in real time out to a tactical formation instead of having to wait until the next capability set? Or maybe you're already there, I don't know.
Yeah, so what's great about partnering with our Army G2 is that Mr. Leo Garcia has the authority to help us to be able to get to continuous ATO. So right now, Orion Forge, our DevSecOps environment for tactical and our warfighting mission areas, is currently in a cloud environment. We ask our developers to develop low, so that they have all the means and the tools to, that they can actually develop with. And then we have an automated way and a cross-domain solution built within that environment that allows us to push our code all the way up to the, to the classification where we can need that code. And so we are partnering with several units right now to be able to push automatically code to them. So we're actually taking men out of the loop, right? And so trying to do is more automation than we've probably ever seen before when it comes to DevSecOps and what we're trying to do in this cloud environment. And giving them the ability to use the software in relevant environments and provide fast feedback, right? And so that's in terms of even the system within Orion Forge allows you to do a lot of automation with trouble tickets, but you can also call your developer and also have that dialogue, but you're doing things in more real time than we've seen before. So yes, that is definitely a really exciting area to be able to implement some of the things that really industry has provided to us with DevSecOps and cloud environments.
Ken, I want to return to something that you were talking about earlier with not necessarily sending kit to every single unit. I think that's actually going to become real in some of the National Guard and Reserve units where they start to train purely in the cloud rather than on physical kit that the Army gives them, because now you can do that. Is that about right?
Yeah, so it kind of leans on the things we were just talking about, with Porsche and all. So first of all, originally we had started a question of cost. What is this going to do? We're going to save money going to the cloud. In reality, if I'm still buying a server and licensing all the software, I'm still buying one for every unit in the Army effectively, and now I'm on a cloud. I'm not saving any money, right? Because we pay for those servers whether they're turned on or not. And when you have a lot of the Reserve and Guard units that aren't operational all the time, they're showing up for their 1 weekend a month or training events and things like that. We pay for the server when it's sitting in a closet somewhere, and that's so one thing is being able to rapidly provision the servers on demand as they need them, and to compensate for them not having that kit in their possession, they can get to the cloud and function on the cloud as if they had a real server in their inventory. And they can only do that where they have the appropriate communication backbone to do that. So that would be, we talked about home station mission command centers, training centers, reserve centers. Commercial access to network is relatively cheap and obviously available. You just have to put it in and pay for it. And so there's a trade there of upgrading a lot of the Guard training unit centers and the like, so that we can have these folks log in with their CAC card or a SIPR token, whatever it is, and do their job natively in the cloud in the absence of having expeditiary kit in their possession. Which gets us to kind of a second order effect, that is, if I don't have to issue all that software, I can issue the kit to the units that really need it faster, because right now it takes probably about 5 years to touch every unit in the Army. If I can knock out 2/3 of them because it's Compo 2 and 3, then I can probably refresh it in less than 2 years, which is a very appreciable number from a technology deprecation cycle, right? So now I don't have 5-6-year-old servers out there. And at the same time, the units that wouldn't have been refreshed that fast are working on the same exact up-to-date software that the Compo 1 units would have. It gets to what Portia said about the DevSecOps. We can have the latest and greatest available to everybody. They all train on the same stuff, same capability, without having to wait for a refresh cycle because it's on tap through the cloud. That's huge. Right now, we have an effort in cooperation with TRADOC and Army University to put our CPCE kit in the cloud to support the Command and General Staff College and their curriculum. It's a monstrous, when I first saw it, I said, that's great. And then they told me they're going to have 500 plus students, some of them logging in distantly because they've got foreign students participating in the school. I said, wow, what an opportunity to really stress out the system and see where it's going to break and see what value we can have in managing the curriculum, the training scenarios and all of that. We can learn so much from pushing that initiative. And it's a great thing that's going on right now. And they're shotgunning it. The talent of the soldiers at the school and in TRADOC schoolhouses that that are driving this. These are green suiters mostly, and it's just great to watch because I just have to take notes and say this works, this doesn't, and then put that on contract and make it a production, make it a capability that everybody can get. And we're working really hard now. The training opportunity is just so rich in our ability to learn lessons because we can work within the constraints of an unclassified environment, and we can work at pretty large scale. We can work on networks that are pretty reliable, and we can take what we have and really evolve it. And then at the same time, we're talking to operational units, and they want what we have as well. And we've got some great technology demonstrations and things going on with units that we learn more than we can kind of consume at this point, and it's great because I'd rather be driven hard to evolve the capability to meet their requirements than to try to guess and figure out if they're going to like it or not. And it's just such a great opportunity and a great time to be here working on this that I can't emphasize where we're going. This is going to be a fantastic place in a few years. Over.
There's plenty more to talk about, but that is a good place to leave it. And unfortunately, we do have to leave it there for time. Thank you all very much, Alex Miller, Portia Crow, Ken Lawrence, and really appreciate you taking the time to do this with us. Tell us where things stand in the tactical side of cloud. Appreciate it. And now we'll send it back to the studio. Jason, take it away for the remainder of our day of the DoD Cloud Exchange.